welcome back. In this video, I'm going to show you how to substitute the formula for moles into the ideal gas law so that we can easily solve for the mass of a gas. So we should remember that moles, to find the number of moles, we need the mass of our sample over the molar mass of our sample. So we can put this into a formula. N equals m, lowercase m, that represents mass, over an uppercase M that represents the molar mass of an element. And remember, molar mass we find on the periodic table. And if it's the mass of a compound or a molecule, you need to add all of the elements together that are in that compound or molecule. So we can put this into our formula. We have PV equals M over M, and then RT. And if I want to solve for mass, I'm going to multiply M to the other side and then divide by RT. So I'll have lowercase mass equals PV times M, the molar mass, over RT. And let's try an example really quick just to make sure you understand how this formula works. If we had this question, what mass of bromine gas would exert a pressure of 2.5 atmospheres at a volume of 6.5 liters and a temperature of 500 Kelvin? Instead of solving for the number of moles and then converting, we can just start out by solving for mass using this formula here that we just wrote out. So M is equal to PV times molar mass over RT. Let's double check our units. We have atmospheres, liters, Kelvin. So the R value that I need is 0.0821, and the units for that are atmospheres times liter per mole per Kelvin. For pressure, I have 2.5 atmospheres. Volume, I have 6.5 liters. And temperature, I have 500 Kelvin. And my molar mass, let's see, I want the mass of bromine gas. Bromine is always found diatomically, so I need the mass of two bromines added together. And if we look on the periodic table, the mass of bromine is about 80. So I'm just going to round up to 80. So that will give me a mass of 160 grams, and this is molar mass, so it's grams per mole. So let's plug in everything that we know. M is equal to 2.5 atmospheres times 6.5 liters times 160 grams per mole over R, which is 0.821 atmospheres times liter per mole per Kelvin times 500 Kelvin. So before we move on, let's make sure that our units cancel. We're looking for the mass, so we should be left with grams. Atmospheres cancel, liters cancel. For moles, I have over mole, so that should technically go on this side of my fraction. And then I have another fraction with a mole on the bottom. So those can cancel because they're on either side of my fraction. And same thing with Kelvin. I have one on the top of this fraction and one on the bottom, which does leave me with grams, which is perfect. So just put this into your calculator, 2.5 times 6.5 times 160 divided by 0.0821 times 500. And that should give you 63.3 grams of bromine gas in this sample. I hope this was helpful. This is just a little bit easier than solving for N and then going into grams using a conversion factor. It just combines everything into one formula, which is nice and hopefully easy to work with. Thank you so much for watching. If you have any other questions, be sure and check out my other videos. Thanks for stopping by.